Hello students, welcome back. We are continuing our stationary points journey today, but this time we're going to learn a few nifty things that the ClassPad can do to help us, and we're going to apply our knowledge to a test question as well. So this is all about bacteria in a student's lunchbox, a certain amount of minutes after someone's put their hand into it. That sounds delicious. We're also going to find the rate of change, so we'll use some derivatives for that. And we're also going to use calculus techniques to find the maximum number of bacteria present in the lunchbox. Delicious. Okay, so the function that we're working with today is this one. We've got b of t equals 4,200 plus 900t plus 30t squared, take t to the power 3. And the domain in which this applies is when t is greater than or equal to 0 or less than or equal to 40. So the first question is, how many bacteria were in the lunchbox after 6 minutes? So the temptation here, right, is to take our function, type the whole thing in our ClassPad, but substitute 6 for t, which would absolutely work, but we're going to need to use this function a bunch of times over the next the next few minutes that you'd be answering this question. So what I'm going to suggest that you try for today is give defining the function a go. And the way that you do that is we go to interactive and then you go down to define at the bottom. And now we're going to tell the ClassPad what the function that we're working with today is. I'm going to throw a little caveat at you though. Our function in the question is b of t. I've left it in the ClassPad as f of x, and there's one big reason for that. The first one is that x variable there, we've got an x button on the front of the calculator, so anytime we need to type in x, it's just there on the front, so we can just hit it really easily rather than go through the menus. And similarly for the function name, I haven't changed it to b of x, I've just left it as f of x. And all that means is whenever we calculate the outputs for any of these functions, we just got to remember that f of x from the ClassPad is the same as b of t when we're talking about this function. Anyway, so what you do there is then enter your expression here. So I've gone 4,200 plus 900x plus 30x squared, take x to the power 3, and then I'm going to hit OK. And then once I've done that, the calculator is going to tell me that I've done it. Thank you, calculator. And the neat thing here is what I can do now that I've defined that function, I'm going to highlight f of x just here and copy it down to the next line. And when I copy it, if I've highlighted it, I just drag it down to copy it to the next line. And then I'm going to swap out the x in f of x for a number 6 and hit enter. And what that'll do is evaluate what f of 6 is, which for this function would be what b of 6 would be, and that is for an answer of 10,464. So then your actual answer to this question is b of 6 equals 10,464 bacteria. So that's worth 1 mark. We get 1 mark for answering that. Hooray, go us. Moving on to the next question. Okay, we now need to find the rate of change of bacteria after 10 minutes. So straight away we see that that phrase rate of change and we start thinking derivatives for this one. Now, what I'm going to do now, because I've already defined my function here, what I can say to the calculator is, hey, I want the derivative of f of x. And the way that you do that is go to Math2 just here, and then you click this button here, which is our, well, one of the derivative buttons available to us. That's the one we're going to use today. And then that's going to go up here and it's going to be d over dx. And well, actually, no, it won't put the x there. We've got to put that there ourselves by hitting the x button on the front of our calculator. So that's another reason why it's easier if we just stick with x for this one. And then we're saying that derivative with respect to x, and we're going to find that of f of x. And again, because I've defined that up here, I can just highlight the f of x that I've got just there and drag it down into this expression just there. And if you hit the execute key, it's going to tell you what the derivative of that function is. And that's going to be our first line of working out. We want to tell the person marking our paper that the derivative of t with respect to b for this question is going to be negative 3t squared plus 60t plus 900. But we want to evaluate this when t is equal to 10. And the way that I can easily do that on the ClassPad is to go down to Math 3 down here. And then I'm going to hit this vertical line button just there. And then up here, I'm going to, once that vertical line's appeared, I'm going to say, hey, I want to evaluate the derivative of f of x when x is equal to 10. And if you hit execute, it's going to spit out what the value of that is, which happens to be 1,200. Now, in the context of the question, it's asking for the rate of change of bacteria. So it's 1,200 bacteria. And if we think back to the question, it was how many bacteria, it was after a certain amount of minutes. So we can infer from that that that's 1,200 bacteria per minute. All right, we are making good progress. We're going to move on to the last question now. And this is going to require a different location for my head because there's a lot going on in the next part. Oh, yeah, the marks for this one. 1 mark for your derivative, 1 mark for the answer. Hooray. Okay, here I am at the top of the page, go me. So we're going to use methods of calculus to determine the maximum number of bacteria when this occurred. So now our calculus brain goes, okay, I've been asked to find a maximum. That means I'm going to need a stationary point. So what I'll do is, this would be my working out for this question. I'm going to write down what my derivative is. We've already figured that out in the previous part of the question. I'm going to set it to 0 because the gradient at the stationary point is going to be 0. And then I'm going to use my calculator to solve that for us. So to get solve up, I'm going to go action, advanced, and then solve. But similarly, kind of like what we did before, I've already got a lot of this in the ClassPad already. I'm going to grab my ddx f of x from this question. I'll highlight that and drag it down. But I want to solve it when the derivative of f of x is equal to 0. And your calculator is going to spit out this as an output. So that'd be your next line of working out. We're going to say, hey, I got my calculator, so CASSOLVE. It's important when we use the ClassPad to say what functionality we use. So I've used the solve function and it gave me the outputs. T equals, well, the input required to generate that output is either t equals negative 10 or t is equal to 30. So we still have to include that as part of our working out, but we do need to think about the question that we were given at the very beginning, where we were given the actual function itself, but we were also given this domain restriction here. So we're only interested in t values between 0 and 40 inclusive. So what I'm going to do on my working out is say that I'm going to reject this answer of t equals negative 10, and I'm going to just use this t equals 30 from now on, because this one is going to be outside the domain for the question. Okay, now what we have to do, so part of this idea of using the methods of calculus is justifying that this stationary point that we've got here is a maximum and is going to actually allow us to answer this question here. So there's two main ways that we'll do that in year 11. One is using the sign diagram that we had in the previous video. The other way that you can do it is use a diagram of the actual function itself. So what I've drawn here is I've got a negative, it's a negative cubic, but I've called it t to the power 3 because it's in the context of the question. And that's going to give us this kind of shape. We've got that decreasing from left to right, increasing, and then we're going to start decreasing again. So our two turning points that we have, the one on the left is going to be t equals negative 10, and the one on the right is going to be t equals 30. And we know from the shape of it that the one on the left is going to be a minimum and the one on the right is going to be a maximum. So what I've done there is used a diagram to justify that t equals 30 is going to be a local maximum. If you prefer, the sign diagram for this would look a little bit like that. So we've got at t equals 30, we've got a gradient of 0. Just to the left of that, we've got a positive gradient. Just to the right of that, we've got a negative gradient, meaning that we're going to have a maximum at that point. So if you want a diagram like this, great. If you prefer a sign diagram, great. Either for year 11 at least, either is okay. Anyway, well, now that we know that the maximum occurs when t equals 30, all that's left to do is to plug t equals 30 into our original function. And again, because I've already taken the trouble to define this in the ClassPad, now I can just find f of 30, which is going to give me 31,200. So then for my working out, b of 30 is going to be 31,200. And then my actual answer is, like answering this worded question, we're going to have the maximum amount of 31,200 bacteria when t is equal to 30. And for this particular test, the marking key worked like this. We had 1 mark for each of the solutions, including the one that we rejected. 1 mark for the justification that t equals 30 was a maximum, either by a diagram or a sign diagram. And then 1 mark for substituting and evaluating our final answer. Okay, that's it. So we'll apply this to another test style question tomorrow. But until then, enjoy your day.